Hello everybody, welcome to another Boost Knowledge video. This video will be about science. Yes, we are starting a new series of lessons called Science. This lesson, we're going to talk about chemistry, and we're going to talk about amazing facts of the atomic model and the periodic table. I have some good news because our channel has now reached 1 subscriber. This is nothing to be proud about, but thank you whom has subscribed, and just please subscribe for more. It really benefits a lot. Let's start this video. The history of the atomic model. So in 1803, John Dalton thought that all atoms were of a round shape and different atoms had different sizes. So at that time he thought that everything we had was made of small round balls called atoms. They were the smallest things something could get. However, just a century later, in 1897, J.J. Thomson rebutted John's idea. He discovered the first electron, which is a subatomic particle, which means it's smaller than an atom. Thus, he proposed that there would be small electrons in the atom, while the rest of the atom would be positive. So it would be like a plum, where there were seeds in the plum, but the fruit, where the fruit of the plum is, would be positively charged, where the seeds would be negatively charged. Thus, each atom had no charge. This model was known as the plum padding model. Then in 1909, Ernest Rutherford made his gold foil experiment, rebutting the first J.J. Thomson and John Dalton's experiments. He shone positively charged radiation into a piece of thin gold foil. Most of the radiation passed through, but some bounced back. Then he knew that the atoms were mostly made of empty space. This is true, and also has a nucleus in the center. 4 years later, Niels Bohr created the fixed shell model, showing that electrons orbited the nucleus, and these electrons could only stay on the rings surrounding the nucleus. Finally, in 1932, James Chadwick discovered neutrons, and they stayed with protons in the nucleus. He also found that electrons were negatively charged, neutrons had no charge, and protons were positively charged. The atomic model was finally complete. The structure of an atom. So our atomic structures are now based on Bohr's fixed shell model. All evidence we have now show that his model is correct. An atom has a nucleus consisting of neutrons and protons, of course. Electrons orbit far away around the nucleus on their fixed shells. And protons are positively charged, neutrons have no charge, and electrons are negatively charged. And now we are going to show you a model of an atom. So the electrons, which are the electrons, which are in blue, they orbit around their circles around the atom, and the orange bits are neutrons, while the red bits are protons. So the neutrons and protons cluster together, and they form the nucleus. Now we're going to talk about the real atomic model. You might be confused. Wasn't that atomic model the real atomic model? There was thousands of evidence to support it. That's Bohr's model. But, well, the real atomic model in real life isn't really like that. Atoms are extremely small. In this condition, a proton is 1.68 times 10 to the negative 17th power. I forgot to make them smaller. Just forgive me. While neutron is 1.6 times 10 to the negative 17th power meters. While an electron is even smaller, 8.5 times 10 to the negative 21th power meters. When you think this is not a big number, a proton's diameter is 0.0000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000 electrometers. And actually, electrons are 2,000 times smaller than this. Atoms are really small. And it is probably impossible, to see atoms, but you can see them in a scanning tunneling microscope. One of the most powerful microscopes on Earth. The relative mass is also incorrect. A proton weighs about 2,000 electrons. If a proton was a stadium, then an electron would only be a medium-sized bus. Also, the electrons orbit far away from the nucleus, at 15 protons length. The electrons orbit so fast they cannot be seen by the naked eye, even with a scanning tunneling microscope. That's when you use the microscope to see atoms. They are only round balls. Why do you not see neutrons, protons, electrons? Because they orbit so fast you can't even see the electrons moving. They're like a great cloud of mist. Also, the speed is close to the speed of light. That's why you can't see them. That's 1 followed by 12 zeros times per second. The periodic table. The periodic table, with its full name, the periodic table of elements, is a table consisting of all the existing elements. So there are 118 currently existing elements, from hydrogen to oxygen to gold to xenon. But how do you read the table? There are a few easy steps. So to the right is a chlorine atom. At the top left number, 17, is the atomic number, which determines the number of protons and neutrons in the element. And below we have Cl, a symbol of chlorine. On the bottom side we have a strange number, 35.4527. When you're wondering what's that, that is the average number, of neutrons and protons in the element. We can deduce the number of neutrons by this number. However, you have to do some calculations. You subtract the atomic number 17 from the number, and here we get 18.4527. That is now the average number of chlorine neutrons you can get. But why is it a decimal? Actually, the neutrons here have no charge, so you can change the number of neutrons according to which chlorine atom. So there can be 19 neutrons in the chlorine atom, 20 neutrons in the chlorine atom. But these types of atoms are really, really rare. And to get the most common atom, you round this decimal 15.4527 to the nearest whole number, and ta-da, you get 18. So chlorine has 17 protons and 18 neutrons. And this is the end of lesson 1, the atomic model and the periodic table. And this is the first video in the science series. I hope you have enjoyed this video very much. The next video will be about physics. Please subscribe for more. Thanks for watching.